The big picture goals of our research are to gain a better understanding of regional air quality, local air quality, and ultimately global climate and global climate change. So I study wildfires, which is fun in its own right, and then I do it using airborne-based measurements. So we use aircraft to sample the wildfires. So at a base sense, we will load our equipment onto an aircraft. We're usually with a whole suite of other instruments and science teams, and then we'll kind of go out in the field, and when a fire crops up, and there's ways that we kind of are in the right place at the right time for these big wildfires. When a fire crops up, we fly out to the location and we'll literally fly through the smoke plume, and then we take samples, and what we're looking for are these little trace gases that are present all around us in the air, and every single smell, every car exhaust, your breath, trees are giving off all of these unique trace gases, and we're interested, or I'm specifically interested in the ones that are coming from wildfires, and how much are they, how much are wildfires giving off, what kinds of gases are these wildfires giving off, and then what are those going to do to the people like firefighters that are breathing it on the front line, the people that are breathing it downwind of the fire, and then ultimately how the global climate will be affected by these trace gases. My research project is, it's not just me working on it. There's a bunch of other, hundreds of other scientists, thousands of other scientists even, that are specifically interested in wildfire research. I'm just looking at one very small part of it. But ultimately, I think, after I'm done looking at this, there's plenty of people that are going to still be kind of looking in the same area that I'm looking. But I think in general for fire research, a lot of it is going towards box modeling or computational chemistry, which is very exciting. Being able to kind of look at the big picture of a wildfire from the comfort of your desk and not having to go out and look at, get on the plane and fly through it and, kind of be in the hot seat for it. And going back, satellites are also a huge asset to fire research, and we're always coming up with better satellites, better measurement, more accurate, more precise. But I think there will always be a need to get out and see the fires and measure them in situ. Inherently, the research is collaborative. For my specific work, I've collaborated with Dr. Emily Fisher at University of Colorado, Colorado State University. I always get those two mixed up. Working with her, learning how to use positive matrix factorization to work on my research, so we collaborated on that. And then I also worked with the National Center for Atmospheric Research doing a graduate visitor fellowship. And I was working with them because they're always going on to new stuff, and sometimes data that they've collected kind of gets a little dusty. It doesn't get looked at in a while, so I was there to kind of look at some old data that they had collected, and also collaborate with some folks there to do some box modeling. So I don't know how to do box modeling very well, but they have a supercomputer. They know how to do it. They're some of the best people in the world doing it. So it was fun to kind of give and take a little there and work with them to do some fun research.